Thank you. I will not say it was a trick to get some comments on the chat, because I genuinely forgot to switch on the mic. But I'm very happy to have comments so that I know that there are some viewers. So thanks. Yeah, so I was saying, like, as a French meme, you know, meme Marceau, I was just explaining what maps were about. So let me redo that super quickly. A map of science consists in projecting on a paper, on a surface, all the journals where scientists publish their articles. You have about 200,000 journals you know, that OpenAlex Foundation is collecting. So 200,000 journals on a map. And the point of this map, in order for it to be insightful, is that the journals should not be scattered randomly on the map. Their position should be meaningful. So how do we do that? The classic way is to find similarities between journals, and if the similarity is strong between any two journals, then these journals should be located near each other on the map. That's it. If you do that for all journals, I hope we're going to see that. Not today, we have much to do. But if you apply this logic to all journals, you will realize that the shape of you know, the shapes that you see on the map are not random. You see kind of continents emerging. So we made good progress in this direction. Where we stand so far is that we have collected 20 million journal articles. It took a day. Then the next steps were about so Nia, for the voice, there is not much I can do. Strange. Let me check my... Let me check something. Okay, Nia, I won't spend too much time on that, just curious. And I do confirm that I understand nothing about the advanced properties of OBS, so not much I can do, sorry. Yes, so we have collected 20 million journal articles in the form of a JSON, big JSON file, 65 gigabytes. And then the next steps consisted in extracting the relevant information from this file, which is full of, you know, rich information. We just need the IDs of the journals and the authors who published in these journals, because the trick is going to be that two journals are going to be similar if a number of authors have published in both journals. So if I take an author and this person has published in journal A and B, well, A and B, journals A and B surely have something in common. And if many authors have published in A and B, well, the two journals probably belong to the same field. So I cheated a bit between the stream of last week and this stream. I did open my coding environment to make some progress so that today we could really start on new things. So this is the coding files, whatever. So if you are curious, because I'll just push the latest on GitHub, let me share with you the GitHub repo, because it's opened there. If you are curious to just browse with me. Okay, I post it here. On the chat, you should see it. And I've updated the README file so that if you click on just look at the README file. I'm going to show it to you here. Yes, I've added this thing. Where is, if you are interested in the code, where do you look at? And just click on this. And this file or class, as we say in Java, is the entry point. This is the launcher. This is the bit of code that launches every other bits of code. And so this was the first thing, to collect all the works from all the articles from OpenAlex. And since I've done it, I have commented out. I've just passed the code into comments because I will not execute that often. Then this thing was just to make sure that the file was properly formatted as a JSON file. I've commented that out because it's finished, it's done. Then, yes, then that's what I did this weekend, basically. I just filter out the non-relevant information in the file, and that's great because we go from a file that was 65 gigabytes to 1.2 giga. And that's great because 1.2 gigas, it means I can just put it on my laptop and work with it. 65, I can put it on my laptop, but it's not super comfortable. And the last thing I did again this weekend was that. It's just a way to take the list of journals and authors and format it in a way which is ready to be used. Let me show you how. So let me show you this file. So it's almost 1 giga big. So I did not put it on my computer. Well, I could have. I just put on my computer here a sample of 50 megabytes. So really something I can open, I hope, in my text editor just to show you. Yeah, great. Takes a bit of time, but can you see it? Yeah, so of course it's ugly, right? But let me zoom in for you. It's super simple. Of course, it looks like complex, but look. Let's take the first line. You see that you have a pipe, a vertical bar. Before the vertical bar, so that this thing here, this is the ID of the journal, of one journal. And after the vertical bar, separated by commas, these are the IDs of the authors who published in this journal. I did not collect all years, because that would be too much. These are all the authors who published in this journal for the last 8 or 9 years. We would have to check the code, but it's like since 2015, I think. So that's exactly what you have per line. So this is a very small journal, like nobody, look at that, a very small number of authors published in it. It's quite suspicious. Maybe what I'm going to do is I'm going to look for this journal with you so that we can understand exactly, this is the ID of a journal, but what is this journal? How do I go back from a very dry ID to a fully hydrated journal profile? So you just copy that, then you open the OpenAlex website, So of course you can do that with an API, but here we are just doing that as humans. So you open Alexa. Okay, sorry, it's going to take just a bit of. So this is the documentation for the API. I'm looking for sources. Yeah. Source object. So a source is, you know, a place where science is published. So most of the time these are journals, but not always. That's why they call it source, not journal. But basically that's our journals. So what's the ID? Ta-da, ta-da, look at that, ID. Oh, you don't say it. ID. So an ID is simply that. You know, https openalex.org/s for source, and then followed by exactly the numbers we had in our file. So let me copy the beginning of the thing. I'm opening a new tab. I'm pasting that. Now I'm back to my file. I'm copying the ID of the journal. I'm back to my tab. I paste it. There, you see. Enter. And there is nothing, of course. That would have been too simple. I don't know what happens. Shit. Oh, yes, yes, yes. You see? I should... Oh, no, you don't see. I think that the proper way to fetch a journal or any entity is by actually using a slightly different URL. So let me copy paste it. Oh, why can't I copy paste it? So let me open it. Okay, so that's for a random article, this one. And I just want to show you, not for an article, but for a source. So sources S, and then this thing here. And hopefully, yes. Okay, this was just the URL, which was not great. Okay, so the weird journal that has just a few authors. It's a French journal. I'm French, so I can understand. Repère cahier de danse, which would translate into... It looks tiny indeed. The booklet for dancing. It's super weird. Anyway, we can have a look at that. There is a URL. Why do they have so few authors? Oh, maybe it was short-lived, like it was published a year. Or maybe it's a new one. No, it's not quite, no, it's not new at all. Repère cahier de danse. Why so few journals? So few authors? Okay, so that would suggest that the data in OpenAlex is not completely... Either it's not reliable, or I made a mistake in the way I collected data. I suggest we leave that for later. But at least now I know that, okay, there is some investigation to be done. So Nuria is asking, are these IDs that we see on screen, are they Web of Science author IDs? And the answer to that is no. These are OpenAlex IDs, but so you might be disappointed because yet another ID. But the good news is that actually, let me show you. Let me show you an author, like a random author. What I want to show you is that in the OpenAlex data, they use their own IDs, but as far as I remember, they also list the other IDs. So if you look at the profile of somebody, if you look at the profile of somebody, you should be able to retrieve their Web of Science ID, I think. So, okay, Marion Caro, French IDs. Okay, no, so you have the OpenAlex. Let me zoom in for you. You have her OpenAlex ID, that's here. And you also have her, I think it's Microsoft Academic Graph ID here. And indeed, you don't have her WOS ID, or you don't have her ORCID ID, but it's probably because she has none. Either she has none, or OpenAlex was not able to retrieve it. But in principle, that could be featured there. So on Corona, yeah, what you suggest is for Linux. I do have a Linux server for operations that run for a day or two. But what you see on screen is my Windows environment. Okay, so where was I? We have that. Each line is a journal followed after the pipe by a list of author IDs. And what we want to do now is we want to calculate for each pair of journals. We want to calculate to what extent these journals are similar or not. And what is similarity? So just to be, just to be complete, you have many ways to compute similarity. You have, again, that can be quite interesting as a topic. You have the Cossinet similarity, you have the Jacquard similarity, and you have other similarities. And the one I'm going to use, I don't know if it's Jacquard or not, but it's super simple. Let me write it in the chat. Two journals are similar if, no, that's not exactly that. The similarity between two journals is measured by the number of authors that they have in common. So you can't have more simple than that. We're just going to count for any pair of journals how many authors are present in the two journals. Why do I choose that instead of Cossinet similarity? It's because in terms of logic, it makes sense, right? I think it's going to be pretty powerful. And in terms of computation and coding, it also allows me to use sets. So a set instead of vectors. So if you don't code, you don't care. But in terms of if you code, you might know that you have default data structures in code like lists, arrays, sets, maps, dictionaries. And these things are pretty easy to use. And you have vectors, and vectors are often, they are really super normal in data science. But they are a bit more boring to use because you have to install or to check for extra stuff. If you can just work out fine with sets, why not? It might not be the most efficient computationally at some point, but we'll see where we will be there. So let's stop talking and let's do it. We have just 40 minutes left. So it's actually super simple. Let's look at that. Where was it? Yeah, so the last file I created, which is called create list of journals with their authors, pretty explicit. So this, in this file, yes. So this thing is super ugly here. Look at the length. So if you don't do Java, I suppose you are just afraid of this very long thing, but or laughing of it. But it's really just. I'm going to tell you what this is. But first, I'm going to create a new class just for what we want to do. I'm going to do. So, similarities computer or journal similarities computer. I should have rebooted my computer because OBS, I think, is kind of stealing everything. So, okay, let me show you. I'm going to use this very ugly thing. What is that? It's a map. So maybe you know what a map is. It's a data structure. So in a simple way, in simple terms, it's a way to store your data which follows the following rules. In a map, you have one data point that relates to another data point. And then you go to the next, and to the next, and to the next. The rule that you have is that when A relates to B, and then you go to the next line, A has to be unique. When you go to the second line, you are not allowed to reuse A. So A relates to B, C relates to B, D relates to E, etc., etc. So it's exactly what we need because, of course, A, B, C, D, you know the things, they're going to be our journal IDs. And the thing they relate to, these are going to be our author IDs. So instead of saying this relates to that, it's called a key and it relates to a value. So the key is going to, in our maps, is going to be the journal IDs, and the values are going to be the list, or actually I take a set, but think of it as a list of author IDs. So for each line in our map, we have the key, which is the ID of a journal, and as a value, we have the authors that relate to this journal. So first, we have to build this map. The very simple way to do that is just to read our file, and for each line, we put it in a map. So let's do that now. We have a very convenient method in Java which is called read all lines. And that's exactly what we want to do. We want to read all the lines. So the file, what's the name of the file? I think I'm going to just pick it from here. Oh, no, I'm gonna. Okay, bear with me. So what I'm doing now is just, preparation, if you want. It looks complicated, but it's just a way that I can then launch the operations either from this file or later from the other file. So it's like, it's ugly, but that makes life easier later. But at the moment, I fully understand if you find it a bit long. So the name of the file, so how am I gonna call it? Journal and author IDs. So journal IDs and so I should put the address of this file, and the address on my disk is there. Yeah, as I told you, I'm gonna use a sample of the entire dataset, not everything. So 50 megas, it should be super quick to treat. We just want to have a test at a small scale. Yeah. Okay, got it. Oops. And what is it? Well, I think we don't need this argument. Okay, so we read all the lines of this file. And if we read these lines, where do they go? Well, they're going to go in a list of lines, right? We have a list of lines. And, I'm going to use a streaming. So in Java, I suppose everywhere, you can either do a for loop, or you can just stream, which is a fancy stuff. Fancy, it's like more than 5 years old now, but I still consider it fancy. So streaming means that it's gonna, you're gonna be able to do operations on every element of the list, which means every line, without using a for loop. So lines stream for each, so for each line. So we should find a name for each line. We're going to call it line. For each line, do something. And of course, what we want to do something here. Yeah, between these brackets. What we want to do with each line is, I think I have written that somewhere. Maybe I should not redo it. Where was it? Yeah, I've written that here. So I should not. Well, I have written all of that already somewhere. Why? Why did I use that? Anyway, we'll do. It seems I have already written the code to upload all of that in a map. Super. Let's just copy paste. Okay, I've already written the code somewhere because it seems I had forgotten that, but I needed the code at some point. Super. So I'm just copy pasting that. So for each line of the file, do things, and we could write the code there, right? But we're gonna keep it in a separate place. So for each line of the file, call this function, this method if you want. And what is this method doing? It just, well, let me show you the file, but I suppose you guess it. It splits the line, oh, you don't say it. It splits the line so that we can then retrieve the journal ID. That's going to be the key in the map. And for the second part of the line, that is all the values after the pipe, we split them on the comma, and then we make a list of all these different author IDs, and they're going to be the value in our map. But I think I've written the code. Perfect, perfect, perfect. Okay, good. So let's try that first. Does it work? So I'm gonna do that, and then just to check that the map is indeed created. Let's look at the number of journals we have here. We have a lot of journals, but how many exactly? Oh, I think 5,000, that's exactly the number I was. Yeah, 5,000 journals, okay. Oh, I closed the. So we should expect to have a map with 5,000 keys, right? So we're gonna check that. Key, no, I can't get the keys from that. Why not? Oh, because I made a mistake. I didn't select the map. Okay, that's the map, key set, or maybe even just size. Yeah, size should return. So number of entries in the map plus this number, and I would expect it to be 5,000. If not, we have a problem. Why does it complain? Non-static, whatever, okay. Okay, if you insist. Or maybe I could, never mind. Okay, let's launch it. So I expect it to take a bit of time because again, I'm streaming, so it takes all the memory of my computer. So NetBeans, which is the coding environment I'm using, is struggling with the memory it has left, which is not much. But that should take, yeah, look at that. First success, which is a minor success, but we are happy with it. Number of entries in the map, 5,000. Okay, so our loading works. Now what we want to do first is, so basically we didn't compute here, we were a bit, we just load. It was what we just did, was loading. So let's rename loading or load data to map. That's what we did. And now we want to compute similarities. So let's do that. And by the way, it should be, I could make it private just for the sake of private method. So compute similarities this time. And look at that. I'm going to choose the ugly way first, but the robust way. a double loop. Oh no, I could use streams, because a stream, the good thing with a stream is that you can parallelize streams. Parallelize means that, you know, we have several processors on our computer, and instead of using one processor, which is the default, ideally you would use every processor to, you know, to have a task broken down in as many processors as you have, and then they would work in parallel. So first you have to make sure that what you are doing can actually be independently chunked into different subtasks, you know, because things need not to be dependent on each other. Otherwise, if you chunk them, they're gonna ignore what the others are doing, and that wouldn't work. And second, you have to use a programming language that helps you using these different processors without spending a day, you know, on using coding tricks to use these processors. And the good thing with Java is that many years ago they introduced streams to do exactly that. So just look at just above, when we created our map, we used a stream, but we could have used parallel stream, and just by changing stream with parallel stream, just for free, Java makes us use the entire number of processors we have on our laptop instead of just one. So it's amazing. The only thing above here is that I'm not sure I could have made it parallel because of some issues, and we'll see if we have these issues here. So similarities. We want to loop through all the keys of the map, which are all the journal IDs. And we're going to loop them in parallel, so using all the no, I always make this mistake. I'm not looking for, I want the map, not. So we want to take all the keys, all the journal IDs of the map, and we want to loop through them in a parallel way. Why? So if it's, as you see, it's barred, and it means that it's not recommended to use it. Why? Oh yes, I know why. I think I know why. Yes, I think I know why. Let's check that. Yes. Are you ready? I'm gonna just change a letter, capital L with smaller l, and I hope parallel stream will stop being barred. C'est parti. No. Completely failed. Let's try it again. I'm just, no. I thought I had a kind of, you know, expert understanding of the thing, but not at all. Why is it? Oh, because, anyway, long story, a bit long to tell for today, so I'm not going to tell it, but actually there is long parallel stream, which is the method I should be using. But there is a reason behind, which is a bit complicated to tell in a few minutes. Okay, so now the journal IDs are going to be looped through in parallel, so we're going to save time. And then we do for each, right? So for each, I could say, I'm going to say journal. So for each journal ID, and I'm going to call it A because we're going to compare A to B. So I can't say journal ID. I need to to call them A and B in anticipation. So for each journal ID A, look at what I'm going to do. Well, I'm going to loop. I'm going to repeat this thing. That's the part where I'm not super confident, basically. For each key, we're going to loop through the entire file again and to compare it with the other journal IDs. So it's a double loop. If you see, we loop through all the journals, and for each given journal, we compare it with all the other journals. So we have to loop again. This is typically the recipe for something which is going to last forever. So we'll see if that makes sense. And then what we do is we retrieve. I suppose we're going to leave this code out because otherwise that's going to be quite hard to do. Private. So it's not. I keep renaming my things, but it's good practice otherwise. So it's looping through, or it's a double looping through journal IDs. And what we do is compute similarities here. It should return a number, right? So we're going to compute similarities between, okay, so we need between the journals A, between journal ID A and journal ID B. So how do we do that? It's super simple. We just we get the author IDs of journal A. So authors of journal A. We do the same for authors of journal B. And then and I never know how to do that, I just check the intersection of the two sets. On Corona, yes, probably. I'm not super good at that. So at asynchronous processing or a way to run code. But yes, I'm going to use ChatGPT to sort that out. I think you're totally right. So I was saying that we just need to compute the intersection of the two sets. And I wonder if we have that in our methods. I think so. Yeah, I think it's retain all. No, it's the other one. It's is it remove all? Can't remember. Remove all. No. I think it's retain all. Yeah. Yeah. I'm gonna check, right, because I don't want to run things for nothing. And so I'm just afraid I don't want to, I don't know if it's going to modify the collection. You know, if, yeah, I'm a bit afraid that doing that, I'm modifying the map. I suspect that it's possible. So I prefer to create a new set. Which contains all the elements of the previous one. And then I modify the temporary set, not the other one. So I think that's better this way. And we return the size of this intersection. How many, you know, how many authors do they have in common? And that's good. Then what we want to do with this number is simple. If this number is not 0, then we have a connection between these journals. And we should, you know, record it somewhere. So this thing returns a number. Why a? Just, yeah, exactly. So similarity. If this similarity is above 0, then so we should write that in a file. Actually, I could do that because I think I have, yeah, I'm lucky. I've already created this boring thing to basically, you know, write on the file while the thing is running, so I could just reuse it. Where is that? Something like here. Yeah, all this ugly thing is already written, so I just need to go there and where should I do that? Yeah, there. So the similarities should be written in a file called similarities. We good. I just add a clock because I like to know how long these things take to run. Fine, 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 fine. And if similarity is above 0, new string, so how am I going to write that? Yeah, very simply. Journal A plus comma plus journal ID B plus comma plus similarity. fine, and write that Q add, and this thing is going to be returned to disk. So there is something missing here, which is that if journal A equals journal B, we should do nothing. If journal ID A, why? Oh yes, of course, equals, then what should I say? Return? No, it's not continue or return. Oh no, return is fine. Right. Okay, fine. And the other issue we have here is that we're going to compare journal A to B, and then we're going to compare B to A, which is useless because we already have compared A to B. There is no need to do the symmetric comparison. So we knew we would need to check that somewhere. I should do that. How can I make it efficient? Yeah, I think I'm gonna do that. So it's a bit I don't know if it's called that. No. Okay, that's not super exciting, but what I need to do is I need to store the information of which pairs I have compared so that I don't compare them again. But given the number of pairs we have, I can't just use the normal way. I need to use a kind of special why? Fast. Oh, fast. Long open hash set. Okay. That is one. Basically, it's a way to store things, but in a more memory efficient fashion than the usual. Pairs already checked. All fine, I hope. Oh, I hope it is concurrent. Not sure it is. No, because when you do parallel things, you need to make sure that the data structures you use are compatible with a concurrent, with a parallel way of working. Not sure it exists. As you see, we have somebody asked the same question a long time ago. complicated. You're welcome, Nia. Thanks for staying. Okay, so it seems there is this thing here. Let's try that. No. Yeah, it seems it's this thing here. Okay, so we have this thing, and now if we checked A and B, oh yes, how do I, ooh, that's complicated, but we'll do it anyway. That's pretty involved. So I'm going to convert the IDs in strings and then concatenate them. It's really something. All that to avoid comparing twice the same pair of journals, which seems like, yeah, why not? But actually, it's going to make us go from 4 billion pairs to 2 billion. So, you know, it's worth the effort cutting the number of comparison by 2. Okay, get it. And once we have done that, or actually before, that's really, we need something more actually. I think these kind of things need to be tested. But I'm nearly there, nearly there. Okay, so we check that we didn't compare the pair before doing the comparison. If actually the pair was already compared before, then it is in the set. So we do nothing. On paper that works. I would be surprised it would work the first time, but you know, miracles exist. So let's try. I don't know how long it will take. Maybe I should put a counter. Yeah, counters are gonna concurrent counters. Anyway, let's launch and see where and how it breaks. C'est parti. Run. So it does break. Maybe the number produced by and it freezes the computer. So we stop. We look at the files. Did it produce a file? Yes, similarities, but the file is empty. And the issue is that my string is much too long. Oh no, number format exception. Is it too big for a long? I don't know how long can be a long. So let's try it. How long can be a long in Java? How many? 3, 6, 9, 12, 15, 18, 19 characters, 19 digits long, and we were beyond 1900. Yeah, we are 20. So my strategy to just concatenate two IDs doesn't work. I don't know, any idea how to check that two pairs have not been? I could make it, yeah, I could make it a string actually. That would work, okay. So it's not a set, it's a string. But a string doesn't need to be... Yeah, string is... Yeah, you don't need a special... Okay, let's do a set of strings. Or I could do... No, I could do a double. Let's do a double. It's a bit weird, never done that. I suppose it's hacky, but I'm gonna look. I mean, if you are still there, you're gonna be possibly interested in the way I manage that. Yeah, Ancorana, I was so hashing, I'm not really, I get the concept. Oh yes, I get what you see. Why timestamp? Why would be the timestamp necessary? Because hashing a string would not be unique enough? Oh, you mean it's a necessity of the MD5 definition of a hash? Never done that before, but you know, we can try. Let's try that. Yeah. Okay. I don't know how to hash a string. Hash code. Yeah, I get your point. Let's try that. MD5 hashing in Java. That's boring. Yeah, but for MD5 specifically, oh, super boring. I'm gonna follow your link. Yeah, hash code, okay, don't over sweat it. C'est parti. So that's gonna be an integer actually, which takes less space. Thank you, Ancorana, because I suppose that's really the way to go. Why? Oh, maybe it's not integer, it's just int. I suppose it's int. Yeah, exactly. Up. Quite impatient to get to the point where the thing runs. Tuk. That would be nice if that would work. Pretty hopeful. Maybe I'm gonna. Okay, let's try it again. Just showing you the console here. Doesn't break so far. Oh, the only issue is that it can take, like half an hour. So I have 5,000. Yeah, that's pretty much already. That's 25 million comparisons. No, but on Corona, I think the hash, the hash code is enough. Okay, it's super slow, so I suggest we just stop and put a counter to see, how slow this is. It's not never ending. Oh, or we could look at the file actually being generated, and the file remains desperately empty. So there is an issue here. I don't know why or what. Maybe I should debug. Okay, I'm gonna debug things. I'm surprised that there is no thing written. Did I start the, yeah. Okay, I expect something fishy to be going on here. So let's debug, let's stop it and debug it and debug. So let's put a breakpoint anywhere, like here. And let's debug. Okay, enough. Okay, so we are in the code. Okay, nothing weird. Okay, good. We compute similarities. Without a surprise, they have no author in common, because that's going to be pretty rare for any random journals to have authors in common. So there is not a positive similarity. And things continue. Okay, so I'm gonna leave it run for some seconds to see, you know, how fast it accumulates. Oh, that's super fast. Okay, like 1 billion comparisons have been made in a couple of seconds. That's a lot. How is it even possible? Look at that. 1 million. Oh, that's a lot. How much is 5,000 per? So that goes fast. I mean, much faster than what I would have thought. So I don't understand. We have 25 million comparisons, and after a few seconds we are already at 1 million. So why? So we can just wait it out. Let's wait a minute and see why things. If you have a clue, let me know. But at the moment, it seems that, so let's have a look. We are at, oh yeah, maybe things are slowing down because of memory issues at some point. Yeah, I would suppose that's the issue here. We are close to 3 million, but it's as if things were going slower and slower. Let's see. And that would be because of memory consumption. So let's have a look at our memory. So I don't know if you see it. I have opened the task manager on Windows, which is supposed to, it's not opened yet, it takes forever. But I just want to check the memory consumption. Yeah, Uncle Anna, I'm sure I'm gonna have to. Yeah, everything is hanging. So I'm gonna close. $6 million. Okay, it still goes fast. Maybe that in 5 minutes we are at 25 million. $7 million. $9.2. 11. It still seems to work okay, it's just slow but effective. Finished. Why so fast? Oh yes, because it's 25 millions divided by 2. And it took, oh, you don't see it. Oh, you don't see it at all. It took almost 8 minutes, which is super quick for the comparison of 5,000 journals. So anyway, let's have a look at the, oh no, that's ugly, oh no, similarities is 0. It did not write the results. So as if it had never found similar or is my Q completely badly written, or doesn't seem completely okay. So I'm gonna relaunch it, not to redo everything, right? Yeah, right on Corona, but I'm a bit lazy, but you're right. First I need to add 2 lines of code to close the queue when it's finished. I didn't do that. And second, I just gonna add a breakpoint here, and I'm gonna wait a minute. I mean, in a minute I would expect 1 similarity to, to light up. So c'est parti. But you're right, if it doesn't work in a minute, I'm gonna just create just a 2-line sample. Okay, so while it doesn't work, I'm gonna create a file that I know should work. Right? Oh, you don't see what I'm doing, sorry. So a very simple file where basically 2 different journals, but I copied the list of authors from the first one, on the second one, so that there is no mistake possible. Okay, I'm back here, it didn't work. So I'm testing it again on a small sample, small with 2 L's, sample of genre. I'm gonna put a breakpoint somewhere there and launch. So two lines, a file with two lines, and similarity is non-null, is non-zero. So author, 9 authors for journal A, 6 authors for journal B. Is it the case, by the way? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the numbers are correct here. Similarity is 0, even if... Okay, so that's where the mistake. Why that? Okay, so let's redo it again. So the error is there. Why? I don't know. Yeah, that's weird. So it's not retain all. But why? I'm too tired for that. So what does retain all do? Retains only the elements in this collection that are contained in the specified collection. Yeah, then it should work. What's the heck? Oh. I must make a silly mistake here. I just don't see it. Let's have a look. So we have, let's have a look here. Okay, so this one is here for sure. Okay. Okay. Wow. Is it about... I should reread what retain all does. Retains only the elements in this collection that are contained in the specified collection. Removes from this collection all items that are not contained in the specified. No clue. I'm gonna Google it. I'm gonna Google it, or I could try asking ChatGPT. Let's try ChatGPT. I mean, that's why the traffic to Google is decreasing. It's like everybody finds it more convenient to just ask ChatGPT directly. In Java, using the fastutil library, I have two sets and I know for sure that they contain at least one element in common. Yet, when I do the following, when I execute the following lines of code, temp ends up at size 0. Why? Let's give it the names of my sets just to be sure. Let's put some okay, and then let's copy paste my code. Ah. Ah, c'est ce que j'ai fait. That's what I did. It's just crap. No, I think it's crap. But let's check that. No, that's crap. So what's the boolean? Okay, let's check with the boolean. Your code looks like mine, so I don't understand your suggestion. Yeah, makes sense. I must make a mistake somewhere, like a silly mistake. let's try Google fast util retain all method gives 0. Maybe I'm not the first one. Fast util, not fast. No. Complicated issue. Why that? So strange. Maybe, I don't know. Maybe it's just the way I create the temp. Maybe it does that. Come on. Yeah, I'm not sure, encore. I don't know why it would have anything to do with hashing. Because the problem is really located there. I mean, that's super strange that, you know, computing the intersection between two sets that have elements in common, it should not result in a zero-sized set. There is, like, I don't see why hashing would have anything to do with that. Maybe I know. Yeah, maybe I know. Maybe I know. Look at that. Let's do. I just exchanged the two sets, B and A. Yeah, I think it's just the logic of it. Oh, come on. Yeah, it's just the logic of retain all, I suppose. So I just computed the intersection by exchanging A and B, and I would expect it to work now. No, it doesn't work. Shit. J'en peux plus. C'était quoi le problème? Oh là là. For a moment, I thought I had it. No, definitely not. Yes, same in Java. These sets are you can iterate on these sets. I mean, I think there is nothing wrong. The types are long in the two cases. It's really like a puzzle or a riddle or kind of Sudoku or a crossword from the New York Times. Like you're stuck. I will not go past 5 p.m. local time. So I have 12 minutes to sort it out. And just staring blankly will not help me. So I'm gonna Google things. Java. Java set retain all give 0. Yeah, but comparing two sets, it's like, you know, comparing for equality, and yeah, I kind of. Oh, so Ankara, you would suggest that I would do it manually? Yeah, but it's my code is already slow. If I do things manually, I'm gonna, of course, do things slower than the standard reference. It seems it might have to do with the types, and so you were, in this case, you would be right when you suggested to me I should check the types. So I'm just for some obscure reason, maybe that. So the type is long. I mean, there is no reason. There is no good reason for. Should I go with a manual operation? That's gonna be slow as hell. But maybe we can just do that. Oh no, I don't want to write that. It's a double loop again. Okay, let's try that. Awful, but never mind. I'm gonna ask ChatGPT for it. I don't want to write that myself. In Java, using streams, find common elements in two sets using parallel streams. Let's go faster. Yeah, so it gives me a full example. I don't care, I just want the result. Oh, that's super fast actually. Look at that. It's, I mean, fast and quick. Wow, that's crazy quick. Oh, that would be great if that's as simple as that. Oh yeah, there is an issue here. I hope that can work like that. Not sure. Okay, let's try that again. So it was surprisingly short to write. I mean, thanks to ChatGPT. And it's not a double iteration, actually. It's no, of course not. Zero again. I'm gonna kill myself. Why? Why? So there is something that just doesn't work here. Okay, let's check that. Why that? Size equals 0. Okay, I don't care. I'm gonna do things manually and see what's... It's as if the thing here, the set is not equipped with equality or stuff like that. I'm just gonna check that. There is no good reason for it not to work. Crazy. Anyway, okay, let's do it the manual way. Okay, it's really a horse shit. Mystery, total mystery. And if I do that, Hey Ancora, sorry, I just see your question. Let me read that. Okay. I don't. So you want to group articles? Okay. Yes, I think you can. So what I would suggest is, so sorry, I'm just advertising my solution, but let me show you in English. Let me show you something. Where is? Yeah, so if you click there, let me do that in 2 times, that plus. Let me show you. So the first link I shared with you is an app I've created that no, VoiceViewer is great, but it doesn't do what you need, I think. So the first link I shared with you is a tool that creates a network of entities, and in your case, the entities would be the articles, based on how many keywords these entities share. That's exactly what you need, I think. So I tried on the link I've shared to explain, what it does, etc. But then you have Veronica Espinosa, who has written a tutorial on this function, and she just published it. And I think she does a better job than me at explaining the usefulness and actually how to use this function. And the result, if you ask, is not a cluster, it's a network where the connections between articles, you will have connections between 2 articles if they had keywords in common. And then what you can do is, I don't know how familiar you are with Gephi, but actually VoiceViewer, then what you can do, is you can just, you can upload the network that this function has created. You upload it on VoiceViewer or Gephi, and it will, you will see communities, aka groups, I hope it's clear. So you create a network from, with this function. This network, you upload it in Gephi, and then when you, no, but you don't have, the function creates the network for you. That's the point. That would be hard. The link I've shared with you is exactly for that. You give it a table in entry, and it spits out a network. And this network, you open it with Gephi, and each community, if you see what I mean, I don't know how familiar you are with Gephi, but if you run community detection on Gephi on your network, you will find your group of articles. And honestly, that could be super interesting. just to repeat, I have especially, I have, the purpose of this function is exactly for the users like you who, nobody has time to create a network manually, but it's boring to do, to do this function. So I did it once. Yeah, exactly. So what you have to do is simply, what you need is, if you think in terms of Excel, column A, the name, the unique identifier for your article, so maybe the title, but if you have a VOS ID or anything, that would be, anyway, unique identifier of the article in column A, and in column B, comma separated list of keywords. Yes, Nuria, it's normal. It's Twitch. Maybe you have. Twitch can be more fancy, but here I'm just talking to the person who's writing in the chat, Nuria. So maybe you can just. Maybe you can follow like me. I don't hear him either, him or her, by the way. No worries, Nuria, sorry. I hope it's clear, Onkorana. I suppose it's super simple. You have to format your data so that in column A you have the unique identifier of the article, and in column B you have the list of the keywords for this article, but then done. Yeah, you have to, exactly, Zotiro, whatever you do what you have to do, right? But then I hope this function is gonna save your day. In the meantime, I'm still completely, maybe that this little, pause has refreshed my brain. Cheers, Onkorana. I should stop, as I said, but I should stop basically because there is something obvious that I don't see. It's like beginners stuff, and it doesn't work. So my brain just needs to oxygenate, and then a miracle will happen. So Nuria, do you have other trainings on how to produce the list of items or authors? So it depends on what I'm not sure exactly what you need, like how to search for authors or search for articles on OpenAlex. So no, I don't have any training. I just have my Twitch sessions that I record, and then I put them as a replay on YouTube, but that's very much, it's hard to reproduce because I code in Java, so if you don't know how to code in Java, it's not straightforward. I think that, Nuria, if you are interested in that, the best bet for you is, let me show you. Two things, actually. So if you need to retrieve lists of authors, so OpenAlex it's experimental, it's not officially released from what I have understood, but OpenAlex is building up a web interface, where you can search and retrieve stuff. So I didn't check it the last few days, but I think it's not ready yet. but it's going to be ready soon. So do check that. And the second suggestion I would have for you is to check Voz Viewer. It's a free software that you can install on your desktop. It is okay. Thank you, Ancorana. And Voz Viewer is meant to visualize networks, but it also has Voz Viewer also has an interface to fetch data from bibliometric sources. So they have Crossref, they have PubMed, they have Web of Science, and they do have OpenAlex, I think. So I'm not sure it's super easy to use Voz Viewer to actually, you know, you can retrieve this data, but then I don't know how you store it on your computer. But I would really, yeah, I would really recommend you to have a look and, you know, see what can be done. Okay, I have to go now, and I hope that, again, you know, oxygenation will produce a result in the next hours or days. So see you next week maybe. Otherwise, yeah, we'll see how we do some progress in the next few weeks. Yeah, oh yeah, indeed. Have a good day. Thank you for joining. Oh, Veronica, you were here. Do check the tutorials by Veronica on all these topics. I've posted her Medium article above. Let me paste it again. No, not this one. Well, in any case, just check Veronica Espinosa on Medium, and you will find all the tutorials she writes on a variety of tools, software, and analytical approach to text mining and network analysis. Super on Medium, Nuria. So just check that, and you will find her Medium page, and then, you know, it's full of yeah, presentations of tools and tutorials. And it's amazing everything she finds. Yeah, and Veronica has just posted her nickname on Medium. I have to leave now. Okay, thanks again. See you one day. Cheers.